Hello and welcome to this lesson about rational number word problems. The learning target for this video is setting up and solving word problems with rational numbers. I want to start by sharing some tips and process, if you will. So the unfortunate part with word problems is that there is no formula for solving all of them. The biggest piece of advice I can give you is that you're going to have to think on your feet. And what that means is that you're just going to have to take a look at what the problem has and try to take it from there. And so extract some useful information, try to push aside any extraneous, any information that's not really helpful for solving the problem. Often problems will have distracting information. Some of the examples we have today that won't have that everything that's in there will be needed. So the first tip is be ready to think on your feet. The next tip, I'm sure you've heard this one before, is try to draw it out. Sometimes drawing it out or sketching it out, making a picture of it, is really useful to kind of see what's going on. Second, another tip I think that might be kind of useful and maybe you haven't heard too much of before is ask yourself, bigger or smaller? And what I mean by that is, is something happening where a number is going to be getting bigger or is a number going to be getting smaller? Because if it's getting bigger, odds are you're going to be dealing with multiplication or addition. And if it's getting smaller, you're dealing with division or subtraction. And so knowing the direction of the numbers is rather useful. And then that also leads into the third tip, which is, look out for what I like to call operation words. So operations, again, that's where we have plus, minus, multiplication, and division. We want to look out for words that maybe indicate something like that, where we're going to add some stuff together, we're subtracting stuff, we're multiplying, or we're dividing. And again, we're making it easier on ourselves if we do step 2, because if we know something's trying to get bigger or smaller, we've limited our options down to 2 operations instead of all 4. Okay, so now let's take a look at some examples. Our first example, 4 friends go to the movies. They each buy a popcorn and soda, which costs $8.50 per person. How much was spent on popcorn and soda? Okay, so there's a cultural piece here. You're going to the movies, so odds are we're looking for a number that's going to get bigger because going to the movies is expensive. But also, just take a look at the situation. You have 4 people who are each getting popcorn and soda. So, I'll sketch it out here just a little bit. Bear with the drawing, all right? I'm not an artist. Let's all deal with it. Okay, so there's the soda. There's my popcorn. I know, fantastic. And this cost $8.50. And keep in mind that there are 4 of these. Now, I don't know if you saw it, but just by drawing it out, I may have made the problem. I created the equation or the expression needed to solve this because I put this person in parentheses. And if I just put the numbers together in parentheses, I have what I need to do. I need to multiply 850 by 4. And so a couple ways you can go about it. You can sort of rationalize it. And so I could be like, well, all right, 850 times 2 is going to be 17. And then I have to times it by 2 again to get to 4. And that'll get me 34. Or I could actually do the multiplication. 850. Oops, let me clean that up. That's not neat. 850 times 4, and then that's 0, 0, carry the 2, 32, 34, and then add that all, or put the 2 decimals right there. Boom, $34. So, again, drawing a picture kind of helps. Knowing the direction of what was going to happen also helps. And so let's now continue to do more examples and see what we can extract from this. All right, Blake leaves 1/4 of his estate to his high school, 2/5 to the local cancer fund, and the rest goes to his church. How much did the church receive? All right, so let's see here. I think, again, a picture kind of helps us out. So it's not necessarily a cylinder, but I think a cylinder is a good way to kind of represent what we got going on here. This is his estate. Actually, you know what? Let's make it even easier. Let's just make it a rectangle. All right, so this represents Blake's estate. So Blake's estate. 1/4 of it is going to his high school. So this goes to high school. 2/5 of it, 2/5 goes to the cancer fund, and the rest is going to the church. Now, it doesn't necessarily need to be, proportional. This doesn't have to literally be 1/4 and 2/5. We're just looking for a representation of it. And so what we have is one whole thing, and we're taking away parts of it. And so I'm starting to see a subtraction problem here. So this whole thing, again, is 1. That represents all of his estate. And a portion of it goes to the cancer fund. And a portion of it goes to his high school. And we're trying to figure out what's left that goes to the church. And so what I'll need to do here is get a common denominator. And so I'm looking at a common denominator of 5, 4, and 1. And that's going to be 20. So I'm going to have to multiply my 1 by, I'll do this in a different color here, 20 over 20. My 2/5 is going to get multiplied by 4 over 4. And my 1/4 will be multiplied by 5 over 5. So 20 over 20 minus 8 over 20 minus 5 over 20. And now I just work left to right here, 2 at a time. 20 minus 8, 12 over 20 minus 5 over 20. And then continue to do subtraction. 12 minus 5, 7 over 20. And that's how much the church is getting, 7/20. For the final example, let's take a look at this one. Sam needs to cut 76.4 centimeters of copper tubing into 4 equal pieces. How long is each piece? All right, so let's draw our copper tubing. Right now it is 76.4 centimeters. And what we need to do is break it up into 4 equal pieces. So that means we'll break it in half, and each half will be broken in half. Well, these are each the same length, and so what we've done is we've taken this one long piece and we've broken it into 4 different pieces. So there's no word that kind of helps us with that, but what we've done is started to use that word like broken into. And broken into sounds like division. You're putting something into a group. So we have 76.4 divided by 4. And for that, we'll need to do long division. Or set it up as long division. Put a decimal right there. 4 goes into 7 one time. That leaves us with, 4, 3, 6. That goes in 9 times for 36. 0. 4 goes in once. And so each piece is 19.1 centimeters long. So just to recap everything here, tips and process. 1, you got to think on your feet. There's no method for every problem out there. 2, try drawing it out. It really helps. Then think about whether it's bigger, if you're going to be making something bigger or smaller. And then look for maybe some sort of operation words, or try to figure out what the operation is that you need to use. Are you doing addition or are you doing multiplication? Something like that. So good luck with your practice and homework, and let me know if you have any questions.